All right, so we're going to take a look at solving some of these not sure how this, okay. Well, whether you get my mug or not, here we go. We're going to solve some crazy problems here. They can look like they don't have the same bases, but they do. So here we go. So we look at question A, and we have 1/3 to the negative x minus 1 power is equal to, and this is going to get really funky, 9 to the x squared power. We have power inside of power. Well, for us to be able to solve any of these problems, what we're going to have to do is we're going to have to first get everything in the same base. And so I know that 9 is equal to 1/3 to the negative second power, because this whole thing would be equal to 3 over 3 to the positive second power. So I want to go with this because it puts everything in the same base, 1/3. So I have 1/3 to the negative x minus 1 power is equal to 1/3 to the negative second power. But now, oh, look at this fun. Hello. You can take everything to the x squared power. Oh joy, this is awesome. So, okay, so what's it say about our exponents? Well, so when we're taking a power to a power, we have to multiply it. So that means we're going to end up with 1/3 times to the negative x minus 1 power has to be equal to, or remember, we're multiplying these together, 1/3 to the negative 2x squared power. So follow me on this one, folks. If we have 1/3 to the negative x minus 1 power is equal to 1/3 to the negative 2x squared power, then that has to mean, that absolutely positively has to mean, that negative x minus 1 is equal to negative 2x squared. Okay, so let's solve the quadratic. Plus 2x squared plus 2x squared. And that's going to get us 2x squared minus x minus 1 is equal to 0. All right. Looks like it's time to factor. And I know that negative 2 plus 1 is negative 1. So we're going to be able to do this. So again, we're going to have a binomial pair of factors. We're going to have our 2x and our x, because 2x times x is 2x squared. And so remember, we want that negative 1 to be away from that 2x, because we have to multiply 2x times negative 1 to get negative 2x. All right, so now it's just a matter of solving. Well, set each side equal to 0. What's going to make this binomial equal 0? Well, it's just x equals 1, because 1 minus 1 is 0. On this side, we have negative 1/2, because negative 1/2 times 2 is negative 1. Negative 1 plus 1 is 0. All right. So for question A, we get two answers where x is equal to negative 1/2. Oh my goodness. This is when you know it's time to go home. Negative 1/2 and 1. All right, let's take a look at B. Now I'll erase the first one after the second one. I'm not going to use yellow. Yellow is going to burn your eyes. All right. So I know, new rule, I know that a to the 0 power is going to equal 1. That means anything to the 0 power is equal to 1. So here we go. So we're going to say that this 1 is just 2 to the power of 0, because that's 1. And that is equal to 2 to the 4 minus 9x squared power. Who comes up with these problems? My goodness. I'm just hoping I wrote that correctly. Another priceless moment of teacher looking through their notes. All right, well, let's believe it. All right, so that means that 0 has to equal 4 minus 9x squared. Well, this is just a difference of squares. I love differences of squares. So that means we have 0 is equal to 2 minus 3x times 2 plus 3x. Oh, this is great. That means that the answer here, you just solving this, plus 2 plus 2, we can get 2 is equal to negative 3x divided by negative 3 divided by negative 3, and we're going to get x is equal to negative 2/3. But wait, when we do that over here, we're going to get x is equal to, oh my goodness, x is equal to positive 2/3. So there's our answer. I really hope that's the answer. Okay, so last question, best question. Here we go. So this is kind of tricky because we have 3 to the 2x power, and we have a 3 to the x power, and then we have no powers here. This really looks quadratic, and the other two problems, those were also quadratic. So I'm going to make a leap of faith, and I'm going to come up with a new variable. I like k, because that is definitely the best letter of the alphabet. And I'm going to say k is equal to 3 to the power of x. Well, why do I want to do that? Well, I want to be able to do that because then I can say for this problem right here, or the first term, we have k, which is, remember, 3x, and we're squaring it because we just be multiplying it by 2. Multiplying the exponents, and so that would get us 2x. All right. So that would leave me with minus 4k plus 3. Oh, well, I know a negative times a negative is a positive, and a negative plus a negative is a negative. So that means I can factor this out and solve 0 to k minus 3 times k minus 1 is equal to 0. Now this is a really easy one to solve. What's going to make what value of k is going to make these 0? Well, so that's going to say that k is going to have to be equal to 3 and 1. Now, unfortunately, we're not done yet. Why? Well, because we don't want to know the value of k, we want to know the value of x. And so in this case, we have, since k is 1 and 3, we have 3 is equal to 3 to the power of x. What power of x would make this true? Well, clearly, x is equal to 1. For our other answer, we have 1 is equal to 3 to the power of x, so that means x has to equal 0, because anything to the 0 power is 1.